Hello guys, so for today we are going to solve some problems that involve Atwood's machine, and let's start. So we start with two masses that are held while suspended on a frictionless pulley. So we don't need to consider friction here. Their masses are 0.250 kilograms and the other mass is 0.200 kilograms respectively. Compute for the acceleration of the masses and find the tension of the string. So basically, you have to know that the free body diagram is very much important in this kind of setup. So you need to establish first what are the forces acting on the masses in order for you to solve this kind of this kind of problem. All right, so we'll start with drawing. As a physics student, it is very important that you are drawing just for you to analyze it. For me, I've been doing this for quite some time, and I usually still draw. It's like a common habit for me. And okay, let's start. So this is my first time doing this, so I hope that everything's working. Okay, just give me. All right, so let's say that this is the Atwood's machine. um I I don't I am not really aiming for a perfect drawing, just so you can this is just a diagram that you can just analyze, but if it's a perfect one then it's much better. But well, I can't achieve that. So this is M1 and this is M2. M2 is M1 is greater than M2. So basically this will go down. This will go up. That's already common sense. So that means that with that, we can say we can already calculate for the free body diagram here. So we have, there you go. So what are the forces acting on M1? We have T. It's just the same T because it's just one string of the pulley. So this is M1G. So we have T minus M1G is equal to negative M1A. You notice that the direction of the motion in this part is negative because it's going down. That's why it's negative. So with that, we can have tension is equal to M1G minus M1A. All right, that's great. How about the other one? The other mass, which is mass 2, we have this. It's just going straight down. So we have tension minus M2G is equal to M2A. You notice that the direction here is positive because it's going up. So we have tension is equal to M2G plus M2A. Since we have the same tension, we can just equate it to each other. So that means M1G minus M1A is equal to M2G plus M2A. With that, we can just combine like terms. M1G minus M2G is equal to M2A plus M1A. Since we're looking for acceleration, we need to factor it out. Acceleration is equal to M2 plus M1. And this one can be G M1 minus M2. So with that, we can have acceleration is equal to M1 minus M2 times G all over M2 plus M1. Substituting the values, we can have the acceleration, which is equal to 9.8 times 0.250 minus 0.2 all over 0.2 plus 0.250 In my calculator, it said 1.09 meters per second squared. Okay. But if you're considering the number of significant figures, I think it is 1.088 meters per second squared, for as long as you know the solution of this. Now, because you already found the acceleration, you can already determine the tension. You can use this equation or this equation. It really doesn't matter. If you use this equation, you will have tension is equal to M1G minus M1A. Is that the same? All right. Yeah, you can see that it's the same. So I'm just double checking. So that means that we can have tension is equal to 0.250 times 9.8 minus 0.250 times 1.09. So the answer is 2.18 newtons. So there you go. You already found the acceleration and the tension of problem number 1. If you like to determine the tension also using this equation, you can do it, and you will just know that this is already this is also 2.18 newtons.